And finally, there are three types of anomalies that are produced in the database because of redundancy, right? So because of redundant data, there are three types of anomalies like insertion anomaly, deletion anomaly, and update anomaly. So we can avoid this using schema refinement or normalization. So let me show you an example for anomaly. Right. So I have shared a document with you, right? So let us look into the first schema design, right? So in the first schema design, we are going to store student information, like student information and course information put together in a single relation, right? So for example, the first tuple represents S1, student S1 with student name A, course 1, course name is C programming, course fees is going to be 5K, right? So what is the disadvantage in the first schema design is like updation anomaly, right? So like you are going to store the course fees, course information along with the student information. So one fine day you are going to update the course fees of a particular course, like C programming, you are going to update the fees of C programming course from 5K to 7K. So what happens is that we need to update all the values in the fee column, right? So even if one record is left out, the data will become inconsistent, right? So this is known as update anomaly, right? So one fine morning, our department contact number changes, right? So department has an office with a contact number, right? We have student information and the department information put together. What happens? The contact number of a department changes means, is it possible to update the contact number for all the student records? It's quite difficult, right? So even if we update it, the thing is that even if one record is left out, it may lead to an inconsistency because multiple copies of the same data, they may not agree, right? So this is known as update anomaly, right? So in the first relation, we have update anomaly, right? Then we have insertion anomaly. So what do you mean by insertion anomaly, right? So for example, we want to offer some course, Python programming, right? So let us introduce some course C for Python with a course fees 20K. Is it possible to offer a course for which no student has registered? It's not possible to offer a course unless a student has registered for a particular course. So this is known as insertion anomaly, right? So new course is introduced, right? New course C4, course name is database is introduced for which no student has registered, right? So what happens is that to insert, we need to put some dummy data instead of null values, right? So if student ID is going to be a primary key and so on, so it is not possible to insert your course details unless you insert some dummy details, the particular student. So because of insertion of data, it is forced to insert some other dummy data, right? So problem or disadvantage of inserting this data is that it results in inconsistency, right? So if you want to know the number of students, the answer will be uh, 4 students instead of 3 students. So the thing is that here the insertion anomaly occurs because it is not possible to have a course for which no student has registered, right? So whenever some new course is introduced and we want to add the details about the course in this relation, it is not possible to add the details of the course unless we enter some dummy details about the student. Else I will not be able to add the details of the course in the relation, and this is known as insertion anomaly, right? And then we have this deletion anomaly, right? So deletion anomaly occurs, right? So once a student leaves a course, right? So we have only one student, C3, sorry, only one student S3 associated with the course C3 Java programming, right? So one day he completes his course and he leaves the course. What happens? So student S3 completes his courses and he leaves the course. The entire information about the course is lost, right? So he has registered for both the courses C++ programming as well as Java programming. So many students they have registered for C++ course. So you have details about the course C++, right? However, the course details about the course Java programming is lost once the student S3 leaves the course, right? So this is known as deletion anomaly, right? So these are the examples of different types of anomalies that can be present in a relation, right? So the first is going to be update anomaly. So whenever you have a very complex relation, one what happens? It results in inconsistency due to multiple copies of the same data may not agree and it leads to inconsistency. So that's known as update anomaly. Whereas if you are going to store the student details separately and the course details separately, it is very easy to update the course fees, right? So uh, you can revise the course fees easily and you can avoid update anomaly, right? Similarly, insertion anomaly occurs whenever you want to offer a course for which no student has registered, right? So in this case, it's a very complex relation. So it's not possible to add only the course details, right? So you need to add some dummy values of students before adding the course details for a new course. And again, it may lead to inconsistency. Whenever you enter some dummy details about a student for a new course, it may lead to inconsistency, right? So whenever you query the number of students who have registered for the courses in the institute, it may show different number, right? So this is known as insertion anomaly. And deletion anomaly occurs when a student leaves a course, right? So when a student leaves a course, the entire information about the course is being lost, right? Student S3 leaves the course and the entire information about the course Java programming is lost. It's known as deletion anomaly, right? So deleting the student S3 will permanently delete the course C3, right? So what's the solution to anomaly problem? So the solution to anomaly problem is that we are going to go for refinement of schema design, right? So we are going to decompose complex relations into simple relations so that there is no redundancy, right? So the information is stored in a logical format and then there is no anomaly, right? Now let us divide it into two tables, right? So we are going to divide it into two tables: student ID, student name, course ID, right? So a student relation as well as a course relation, course ID, course name, fees, right? So initially we have a very big complex relation where we have both student relation and a course relation put together as a complex relation. Now we are decomposed it into course information separately: course ID, course name, fees, student ID, student name, course ID, whereby you'll be able to join both the tables, right? So course ID is going to be the foreign key in student relation since it refers to the primary key of the course relation, right? Now let us check whether the anomaly is removed, right? So is it possible to change the course fees, right? So it's possible to change the course fees by updating only one record, right? So in the previous case, we have to update all the records. Now it is possible to update the course fees only for one record and you'll be able to change the course fees associated with C programming, right? So the updation anomaly has been removed in this case. Again, insertion anomaly is also removed, right? So it is possible to have a course for which no student has registered, right? So we have a course databases, course C4 with course fees 12,000, for which no student has registered. It is possible to have a course for which no student has enrolled. So again, insertion anomalies has been removed, right? And then regarding deletion anomaly, right? So what happens when the student, right? There are some other anomalies again, right? However, the other anomalies that exist are like there may be some student who has not enrolled for a course, right? So student having no course enrolled, again you need to enter some dummy details. Again, there is some deletion anomaly, right? So it is possible to delete some course which is allotted to some students, right? So even in the second schema design, we have deletion anomaly exist as well as insertion anomaly exist, right? So I hope you can follow it. So the insertion anomaly exists in the course table where it is not, insertion anomaly exists in the student table. So it is possible for some students to be not registered with any of the courses, right? So for example, student S4 with student name B has not registered for any course. So again, to store his details, we have to enter some dummy details about the course ID. So it's known as insertion anomaly. And in this case, whenever you delete the particular course details, right? So there's a deletion anomaly since the C++ course is allotted to course C2 is allotted to some students like student 1 and student 3. So again, there is a deletion anomaly, right? So finally, we are going to again decompose the relation into three relations, right? So one is going to be student ID, student name, and the other is going to be course ID, course name, and course fees. And finally, the last relation is going to be student ID and course ID. Now, is it possible to have a student who has not registered for any course, right? So it is possible to have a student with student ID and student name, and he may have not registered for any of the available courses, right? So insertion anomaly is being removed. What about deletion anomaly? So it is not possible to delete a course if the course is being assigned to some student ID, right? So deletion anomaly is also removed in the third schema design, right? So we say that the third schema design is going to be better than the first two levels, right? Right. So hope you can follow this, right?
Yes, sir.
Right.
Yes, sir.
Right. Example to illustrate the different types of anomalies that exist in a relation, right? So generally we have three types of anomalies, namely insertion anomaly, deletion anomaly, and update anomaly in an that are likely to be present in a relation. So whenever you need to avoid redundancy in a relation and to remove the different types of anomalies that exist in a relation, we go for normalization, right? So normalization is a process of schema refinement where you are going to break a complex relation into fragmented relations such that there is no redundancy. The information is stored in a logical way. The information is stored in a logical format, and finally there exists no insertion anomaly, deletion anomaly, or update anomaly, right? So this is about introduction to anomaly detection and how to avoid anomalies that exist in a relation by using schema refinement. Right. So let me share the PPT now. Right. So we have studied three types of anomalies that are produced in a database because of redundancy. Right. So we have studied about insertion anomaly, deletion anomaly, and update anomaly.